Hi everyone and welcome back. Now in today's video we are going to discuss about the dependency log file. Now many of you might have observed that when you run the Terraform init in the folder where the tf state files are stored, there is also one more file that gets automatically created with the name of terraform.log.hcl. If you are not observed, that is also fine because we are going to start with the practicals from scratch regarding that. However, in today's video we are going to precisely be looking into the importance of the terraform.log.hcl file. Now, before we proceed further, let's go ahead and quickly revise the basics related to the Terraform and the provider plugins release cycle. So one important part that we need to keep a note of is that the provider plugins and Terraform are managed independently of each other and they also have a separate release cycle. Now at this stage we know that there are thousands of providers that are available which you can make use of, and all of those providers have a independent different release cycle here. So let's quickly understand this. So let's assume that you have a Terraform on version 1.2. Along with that, you have a provider plugin of version 1, and which is the provider? The provider is AWS. Now after few weeks, a new version of AWS provider got released, which is version 2. Again after few weeks, a next version of provider plugin that got released is version 3. So the aim here is to understand that the release cycle of both Terraform and the provider plugins are independent of each other. It can happen that the Terraform is still on version 1.2 and there are multiple updates to the provider plugins. Now, although this is good, but this can introduce some challenges in the production environments. So let's go ahead and discuss more in detail. So let's assume that you have written a AWS specific code based on Terraform version 1.2. And when you run the Terraform init, at that time there was only the version 1 of the AWS provider plugin that was available. And you have tested the entire code, you have tested all of the modules in the code, everything is working perfectly well with the version 1 of the plugin. Now after you have created the infrastructure, you have committed the code to the GitHub repository where it will be centrally stored. Now, it can happen that the code that is working with the version 1 of the AWS plugin might not work pretty well with the later versions of the code. So for example, let's say after few weeks version 2 of the AWS provider plugin got released, and maybe after a few weeks the version 3 of the AWS provider plugin got released. Now, someone from your organization, maybe let's say after a month or two, when he downloads your code from the GitHub repository and when he runs the Terraform init, in such cases, which provider plugin will he download? He'll download the version 3 of the provider plugin. And it can happen that your code is not working pretty well with the version 3. Now this can be due to multiple issues. It can be also a bug at the plugin level due to which the code is not working as expected. Now generally this does not happen quite often, but sometimes this is the use case and hence you need to keep aware of. So generally, if your code is not working with the latest plugins, you can look into the issues that the plugin has in its GitHub page, or maybe the plugin has introduced some new kind of a functionality where it expects certain minor modification in the code. Now the question that comes is, in production environments, what is the way in which we can ensure that this code uses only the version 1 of the AWS provider plugin? And the answer to this is the version constraints. So within the code, you can specify the appropriate version to which the code is thoroughly tested and working pretty well. So in here also, in the required providers, you can specify the exact versions. Now, if you look into this screenshot, in the version, you have a specific range. So it can happen that the provider plugin that will get installed, it can be 4.5, it can be 4.6 and so on. However, you can also specify the exact version. Let's say you only want version 4.4. You can also specify that as part of the version. Now, based on the version constraints that you add, and once you run the Terraform init, after Terraform selects a specific version of the dependency, Terraform also remembers that and adds it as part of the log file so that it can use it as default in the future. For example, here as we are discussing, based on this code, a version of 4.2, 4.4, 4.6, any of them can be downloaded. So once a specific version is downloaded, Terraform will go ahead and add the version in a file called as terraform.log.html. So here you see the constraints here is at 4.0. However, the version that was downloaded while running the Terraform init for the first time is 4.62.0. So now what will happen is any other developer who pulls your code from the central repository and when he runs Terraform init, it can happen that 4.7, 4.8 or 4.9 version of the AWS provider plugin was also released. However, the newer version will not get initialized. Only the version of 4.62.0, which is part of the terraform.log.html, will get downloaded. So let's do one thing. Let's go ahead and quickly understand this from practical point of view so that our concepts are clear. So for today's video, in our KP Labs Terraform folder, we have a very simple file called as demo.tf. Now, similar to the screenshot, we have specified a provider and we have also specified the range of versions based on which the provider plugin gets installed. So at this stage, only one demo.tf file is present. So let's go ahead and run Terraform init and observe what are the things that gets added. So from the CLI, let's quickly do a Terraform init. So based on our version constraints, it is trying to find the matching version, and at this stage, it is installing 4.62.0. Now note that in your case, maybe after you try after few weeks, you might see 4.7 or 4.8 version, which matches your version constraints. Now that your provider plugins have been installed, if you open up the folder once more, you will see that a new file called as terraform.log.html has been created. Now going back to our editor, if you open the terraform.log.html, you will see that the constraints as we have defined is available, and also the version of 4.62.0 is added in the log file. So tomorrow, if a new developer downloads the same code using the same version constraints, considering that let's say a 4.7 or 4.8 version of AWS provider has been available, the Terraform will not download that. It will only download the provider plugin that matches the version that is part of the terraform.log.html. Alright. So I hope with this you understood one of the important benefits of the log.html file. Now, one of the question that comes is what happens when you have the log file with a specific version that is available and then you update your TF file to include a specific version which is different from the log file. This is a very important question that comes. So let's say that in here in the demo.tf, we have now specified the version as 4.60. However, in the log.html file that got created during the first initialization, it has logged to 4.62 version. So in such case, when the code is updated, which does not match to the log file, in such cases, when you run the Terraform init again, then it will give you an error. So let's go ahead and also try it out. So let's say that our version is 4.62 here, and within the required providers, I'll remove this and I'll specify 4.60 and I'll save it. Now at this stage, if you'll quickly look into the Terraform, as we saw that the 4.62.0 is installed. Due to some reason, let's assume that there is some issue with this specific provider plugin and you want to switch back to 4.60. So you added the 4.60 version here. Let's clear the screen, and now you want a provider plugin of 4.60 to be available. So what you will do? You'll do a Terraform init. Now as soon as you do that, since the 4.60 is not matching the log file, immediately here you see you got an error. And this is the reason why it is also important for us to understand on how we can upgrade or downgrade to a specific provider plugin, even though it is not matching to the list that you have defined in the log.html file. So as part of the overall upgrade, HashiCorp recommends that along with the Terraform init, you specify the -upgrade option. For example, you see in this screenshot, we have Terraform init -upgrade, and how this time it is using the 4.60 version that you have defined as part of your demo.tf file. So let's go ahead and also quickly look into this. So this time, let's clear the screen. I'll say Terraform init -upgrade. And this time, based on the version constraints, you see the 4.60 version of the provider is getting installed. Now, before we conclude, certain points that we need to keep a note of. First one is that when you install a specific provider for the first time, Terraform will also pre-populate the hash value with any checksum that are covered by the provider's developer's cryptographic signature. For example, if you look into the log.hcl file, along with the version, you also have the hashes that are available. And these are associated with different platforms that the provider version is supported on. So at an overview, this ensures that only the exact version is getting installed. In case if there is a mismatch in the provider plugins and the overall signature, the initialization overall will fail. So this is one point that you need to keep a note of at a very high level overview. Now, before we conclude, few important points to keep a note of. First one is that at present, the dependency log file tracks only the provider dependencies. It does not remember the version selection for the remote modules. And in such cases, if you have those, then Terraform will always select the newest available module version based on the version constraints. So that's a very high level overview about the Terraform log HCL file. And with this, we'll conclude today's video.